All right, let's go over the practice test from yesterday. Some of the answers I'll just put up and you can discuss them. Other ones I'm going to work out from scratch. So number one, if it says classify, you should be thinking, okay, is it angle measure or side lengths? And as soon as you see angle measures, your choices are acute, obtuse, equiangular, or right. Okay, well, it's triangle CDE. Here is CDE. If this angle is 150, what's the angle next to it if they're a linear pair? What is it? 130 is a linear pair to 50 because they're supplementary. 130. So since that angle is 130 degrees, what kind of triangle is CDE? Obtuse. Obtuse. You guys sound confused. You guys know it's not talking about angle CDE, right? It's talking about the whole triangle, right? And it has an obtuse angle, so it's an obtuse triangle. All right, when it says to classify by side length, what are our three choices for side length? Scalene, equilateral, and isosceles. Which one is this? Scalene, because all three side lengths are different. Next one. This is an isosceles triangle. It has two congruent sides marked. You can't just set any two sides equal. You have to set the 4x minus 5 and the 3x plus 20 equal, because those are the ones that are marked congruent. When you set those equal, you're going to subtract 3x from both sides. You get x minus 5 equals 20, add 5, and you get x equals 25. But it says to find AB. AB is right here. So I plug in 25 for x. 4 times 25 is 100, minus 5 is 95. So AB is 95. Questions on that? Now, I could have plugged that 25 in anywhere now, couldn't I? The key to this problem is knowing which sides to set equal. You can't just set any two sides equal. You can only set AB and AC equal. However, now that we have 25, I could plug it in anywhere. What if they asked me for side BC? They didn't ask us for that, but what if they did? What's 2 times 25? 50 plus 41. 91. That's side 91. All right, moving on. I want to make you guys some triangular medallions as gifts, okay? Beautiful gold roping. Okay, you're going to want one. All right, each medallion is an equilateral triangle with side length 8. So each one of these, I would draw it out, is congruent. Each side is 8, which makes the perimeter 24. It takes 24 inches to make one of these. Does everyone see how you're going to have to take 200 and divide by 24 to get 8 medallions? You can make 8 of them if you have 200 inches of golden roping. One short in this class, right? Who's going to be the person left out? Questions on that one? Number 5. I'm going to work this one out. This one's a little tricky. The answer is x equals 1.75. We'll see. Did you guys get that? All right. Did you guys draw it out? It's an equilateral triangle. Each side is 8x plus 14. So I labeled each side 8x plus 14. It told us the perimeter, though. The perimeter is 84. Check your work. If you set 8x plus 14 equal to 84, that is wrong. What did you do if you did that? Not saying you did it, just in general. If someone set 8x plus 14 equal to 84, what went wrong?
You set one side equal to the whole thing.
Yeah, you set one side equal to the perimeter, whereas the perimeter is really, it's an 8x plus 14 plus another 8x plus 14 plus another 8x plus 14. It takes 3 of those added up to equal 84, doesn't it? Did anyone set 8x plus 14 equal to a third of 84? What's a third of 84? You can use a calculator.
It's not one.
What'd you get, Jake?
28.
28. A third of 84 is 28. What does that mean? You take 84 and divide it into 3 equal parts, and it's 28. Cool.
Side is 28.
Each side is 28. So could you have set 8x plus 14 equal to 28? Yeah. Nobody set 8x plus 14 equal to 60, did they? Thinking they're angles. Because the angles are going to be 60, but this has nothing to do with angles. All right, I bet this is the most common way you guys set it up, so let's solve it this way. 8x, 8x, and 8x make 24x. 14, 14, and 14 make what? $42. And I haven't even messed with the 84 yet. Subtract 42 from both sides. 24x equals 84 minus 42 is 42. Divide by 24, and you should get x equals 1.75. And that's all it asks us for. X is 1.75. Make sense?
Yeah.
Number 6. It's a right triangle, and we learned that if you have an acute, the acute angles in a right triangle are complementary. So if they give you one of the acute angles, if you subtract it from 90, you'll find the complement. So 26.3. So this angle up here is 26.3. Questions on that one? Degrees. 26.3 degrees. Number 7. A lot of you missed this on the quiz. If you want to, I asked you guys to correct those quizzes, make sure you know what you did wrong. If you corrected them, it should look very similar to this one. Some of the biggest mistakes, things you cannot do. Some of you set angles N and K equal to each other. But we don't know that they're equal. Some of you added up those angles to equal 180. Well, the 2 angles don't add up to 180. So you have to recognize this one as the exterior angles theorem, which says the exterior angle of a triangle, 126, the exterior angle is equal to the sum of the 2 remote interior angles. In other words, the 2 angles that are far away from the exterior angle added together. That's your equation. And now we can solve for x. 6x and 5x make 11x. -1 and 17 make 16. Subtract 16 from both sides, you get 11x equals 110. Divide by 11, you get x equals 10. And since they asked for angle K, you plug in 10, 5 times 10 is 50, plus 17 is 67 degrees. You'll write yourself a note. That's called the exterior angle theorem. It's in your chapter 4 theorem sheet. It's in your notebooks. We've practiced it. It was on the quiz. Make sure you know how to do it when you see it. All right, number 8. I found the best way to do this one was to draw out the triangles. We know that HOW goes with FAM. If they're congruent, doesn't H have to be the same as F? the corresponding parts. Doesn't W have to go with M and doesn't O have to go with A? And so then I just started labeling things they gave me. So when I start labeling these, they told me W is 44. They told me, so if W is 44, then I knew M was 44, because they're congruent. If F is 72, then I knew H was 72, because they're congruent. So then to find A is right here, couldn't I add up 72 and 44 and subtract it from 180 to find out what the third angle is remaining? What is, let's do this together. What's 72 and 44 added together? 116. So we take 180 minus 116, and what do you get? 64 degrees. So that was angle A. Right, on to number 9. As soon as you guys, are you starting to recognize when you see the word bisect an angle, you know there's going to be two congruent angles? Everybody seeing it? So on this picture, as soon as you see QP bisects angle RQS, here's RQS. It's an angle. It's up at Q. It's the whole angle. When you cut the angle in half, you get two congruent angles. When you name them, they have to have a center letter of Q. So in step 2, I said RQP congruent to SQP. Definition of a bisector. So the pair of angles congruent. Next given, we're told QR is congruent to QS. There's a pair of sides congruent. Then QP, reflexive property, since they're sharing a side. And would you guys all recognize this is SAS? The triangles are congruent by SAS. Make sure when you're writing your, step 5, your triangle congruent statement, CP/CTC will never go with that. You're never going to prove triangles are congruent by CP/CTC. It's going to be SSS, SAS, ASA, AAS, or HL. Make sure you have one of those 5, and this one is SAS. Is this going to be a CP/CTC proof? How do you know? You're proving the triangle is congruent. If you're proving a pair of sides or angles, then yes, but this is not. Any questions for me on number 9? Have you had time to check it and correct it? All right. Number 10. Another bisector. This time, JL bisects, another angle, KLM. KLM. If you cut that angle in half with sound effects, that angle just got cut in half. You see the two congruent angles as a result. Tristan, how did you name those angles?
I named them KLJ and
Perfect.
MLJ.
Perfect. Yep, that's how I named them. Could you have named them JLK and JLM? Yeah, that's fine too. Reason? Definition of a bisector. So that gives us a pair of angles. They're right here. And then we were given K and M were congruent. We already said that. Oh, no. I said that in step 3. K is congruent to M. That's step 3. It's another pair of angles. And since these triangles are sharing a side, we're going to use the reflexive property, JL, JL. Since the angles match up at L, then it's the correct order, JL, JL, reflexive property. So then do you guys see the triangles are congruent? We have 2 angles and a side. Is the side between the 2 angles or not between the 2 angles? not between, so it's AAS, not ASA. Angle side. Two angles in the side, not between them. How you doing that? These should start to look pretty familiar. We've done a few of these that look like this now, haven't we? Okay. 11. When you guys see, when you're given that a pair of segments are parallel, what should you be thinking of? Very good, Cole. Alternate interior angles. You guys see, do you see the alternate interior angles form? Because the lines are parallel. Cool, how did you name those ones?
I did NOM and MOA. Or what?
Can't read it.
No, oh, PMO.
Good. Yeah, just be careful. I still have some people struggling naming these. If I look at this, if I look up here, see the top angle up here? I'll call it angle 1. See this top angle up here? What does the center letter have to be? O, right? So he did that. That's the top angle. And if he went NOM, he went across that parallel side first. So then down here at angle 2, M has to be the center letter. And he went across the parallel side first. PMO. Now, when I wrote it last period in step 2, the person said MON. Is that okay? Yeah, because O was their center letter. They did MON. They went backwards. And if they went MON, then they went OME. Again, what really matters is the center letters match up, and that it could be reversed. If you reverse it, that's fine. The center letter is the important part, as long as you're reversing both of them. But either of those is fine. That's step 2. Reason, those are alternate interior angles. You can only say that if the lines are parallel, and we said that in step 1. And they also gave us that in the given statement, N is congruent to P. So we have a pair of angles, and now another pair of angles congruent. Zachary, are these triangles sharing a side?
Oh, actually, these.
They are, aren't they? And when we see a shared side, we think of which property?
Oh, wait.
Rhymes with reflexive. It rhymes with reflexive.
Flexi.
Reflexive, very good. The reflexive property. So MO congruent to LM. They swapped places, didn't they? OM in the top triangle is MO in the bottom triangle. Let's see what we're at right now. We have 2 angles and a side. That could either be AAS or it could be ASA. Is it 2 angles in the side between them or 2 angles in the side not between them? Not between them, so it's AAS. So do we stop after step 4 after we prove the triangle's congruent? No, this is CPCTC, isn't it? Why is that, Casey?
Because we're trying to prove a line or a segment.
Yeah, we're trying to prove either segments or angles are congruent. So we're going to use CPCTC. So that's only used after we've proven the triangle's congruent. So step 5, and the reason is CPCTC. All right, number 12, when I said show that the triangles are congruent, you had to plug in -6. So -6 squared plus 36. When you guys plug in -6 squared, are you getting positive 36? Be careful, make sure you're putting parentheses around it. And 36 plus 36 is 72. And this side over here was also 72. So these are the pair of sides congruent. We already know 42 and 42 are congruent. And we already know 82 and 82 are congruent. So these triangles are congruent by SAS. This is not a proof. All you have to do is just show the word, okay? and then tell me why that comes out. 14, what kind of triangle is this? Equilateral, but that's pointing at an angle. Well, that's okay. If it's equilateral, it's also equiangular. So each angle 60. So you could have done this one of two ways. Did anyone set 36 minus 2x equal to 60? Good. Did anyone add up 36 minus 2x 3 times and set it equal to 180? That's fine too. Either way, you should get x equals negative 12. Does that bother you, getting a negative for x? Can x be negative?
Yeah.
Yes, as long as when you plug it in, the angle is positive, right? And negative 2 times negative 12 is 24, plus 36 is 60. So that works out just fine. Questions on that one? Last two. When you plug in 25 for y, this top triangle is already solved for. When you plug in 25 for y, you get 7, you get 25, and you get 24. So these triangles are congruent by SSS. 15, what kind of triangle is that? Isosceles. And did they label angles or sides with X's? Sides. So this one has nothing to do with the angles, right? We had to know that since the angles were congruent, the sides are congruent, but after that, we're just setting the sides equal to each other. So when you solve for X, you should get 21. Any questions on that one? All right. I want you guys to spend this time. You should have your chapter 4 quizzes out. I want you guys correcting those. There's a chapter practice test in the book you can work on. Some things tonight. I would have my quizzes out. I would have past homeworks out. I would review problems. In math, you can't just look at the work. You need to practice it. So maybe you take one of the proofs that you've seen a lot of times and you rewrite it on a blank piece of paper and you solve it and then you compare it to one of the ones you've done in class. Or maybe you go back and watch some of the 4.4 and 4.5 videos that I taught a week or two ago, and you pause it and you try one of the proofs in there and then you push play and watch it, see if you get it right. You have to practice some problems, all right? The test is gonna look very similar to this practice test. It might not be as long, it'll be a few questions shorter, but the problems are gonna look very similar. All right, so use this time to practice.